Good evening, thanks for coming. I'm Monty Robson, the director of the observatory, and this is our second Saturday Stars presentation for August of 2019. So, we've got three interrelated programs of science that we do here: asteroid observations, meteor observations, and meteorite studies. So if you're ever driving by and you see something like this from here, you might as well continue to the tavern or to your bomb shelter or something else. But you're not going to see something like that because they're very rare events. Tonight's program will focus on meteorites. So my real beginning with meteorites was when I found a reprint of this article from the Bridgeport Advertiser of Christmas Eve of 1807. As observatory director, I'm always looking for, and still am, topics of interest for our educational programs. But when I found the first sentence of the third paragraph, at New Milford, more than 20 miles from the point of explosion, the shaking of the houses was more severe than nearer the place of its discharge, I said, hey, wait a minute, that's got local interest. Let's look into this. And so I did. And right away, that night, I found there's so much stuff on this that is different. There's a lot of malarkey going on. So I really wanted to nail this and understand what had happened. So this article says it's terrestrial comet. And you gotta love the language back then. It's different than now. On the morning of the 14th instant. Instant means of the current month. So that means on the morning of the 14th of this month happened to be December. So the 14th of December, 1807, a meteor flew over New Milford, exploded 30 kilometers in the atmosphere, and landed in Monroe, Easton, and Trumbull, Connecticut. And they ended up calling it the Weston meteorite. That's because Weston and Easton were one back then. But they never got along, so in, I think, 1845, the state split Easton off of the town of Weston. Anyway, interesting. And that's quite an observation. The shaking of the houses, more severe. Anyway, terrestrial comets comes from this. This is the first paper published in the United States about meteorites. This was by Thomas Clapp, who was then president of Yale College. And that was his theory. Terrestrial comets, he thought, were comets that were in orbit around the Earth as opposed to around the sun. And, well, he was wrong, but interesting. It's a very interesting paper. This was actually copied in his office by a tutor at Yale, copied by hand. But when the British came during the Revolution and burned a lot of New Haven, as they also did Fairfield, Fairfield they really devastated. But they also got New Haven. They took his trunk that contained all his papers, put it on board the ship, and when they came down to get Fairfield, they dumped it in the Long Island Sound. So if that tutor hadn't copied it, we never would have seen it. And then John Trumbull published it in my Roman numerals is right. That's 1781, right? LXXXI. So the definition of meteorite I'm going to use tonight is it's a rock-like solid body that's been found on the surface of the Earth that has come from space and survived its high-speed passage through our atmosphere. We now know that most of them come from asteroids or minor planets, but some are likely from comets, and some have come from the Moon, Mars, and probably elsewhere by the mechanism of energetic impacts. So an asteroid is a solid body in orbit around the Sun that is larger than a meter in diameter. They're remnants of the formation of the solar system. So they're all pretty old. 4.5 billion years old. Okay? Meteoroid is a solid body in orbit around the Sun that's smaller than a meter in diameter. Asteroids are also called minor planets. A meteor, then, is the visible streak of light produced by the high-velocity passage of an asteroid or meteoroid through the Earth's atmosphere, and its duration is measured in seconds. So it's out in space for billions of years. It comes zipping through our atmosphere in seconds, and if it survives, then they call it a meteorite, which is a solid body that's been found on the Earth's surface. This is a wonderful diagram that'll tell you everything you need to know about them. This was done by I found it in a paper by Zdeněk Seplica, who's now deceased, but I was fortunate enough to meet him before he passed away. So here it is, a meteoroid or asteroid is out in space for cosmic ages, 4.5 billion years. And then if it enters the Earth's atmosphere, impacts the atmosphere, and ablation begins after it's preheated enough, it gets hot enough because it's going so fast that it starts melting on the outside of it. This part of its flight is when it's a meteor, and the duration of that is measured in seconds, usually a second or two or less. The longest duration one I've ever heard of was 40 seconds, and I'll show you a picture of that after a bit. Anyway, when it slows down enough because of the atmosphere, then it free falls to Earth. This portion is called the dark flight. Can't see it anymore because it's not luminous anymore. It's slowed down enough that it's not heated up so much to melt, and this is measured in minutes, a minute or two at the most. And then it's on the surface if it's made it that far, and you call it a meteorite. So the minimum velocity that they can impact the Earth's atmosphere is the same as the escape velocity from Earth, which is 11.2 kilometers per second. You say, wow, that sounds like it's quite a bit. It's 25,000 miles an hour. That's the minimum speed. Some cometary fragments come in at 70 kilometers per second. You know, that's about 150,000 miles an hour. So that's why they only last for seconds as a meteor. And don't buy this if you read that, oh, it's caused by friction. Everyone knows if you rub your hands together hard, yeah, they get warm. Yeah, that's friction. That's not what causes them to melt. It's the pressure buildup on front of them. The compression. Air can't get out of the way fast enough. So it's compressed. And that compression raises the temperature enough to melt the outside of them. So when you're in an airliner, up at cruise altitude now, the outside skin of that airplane that's facing in the direction of the wind, that's heated 50 degrees. And that's only at 500 knots, about 600 miles an hour. Heats it up 50 degrees. These are coming in at 25,000. So the compression is a lot more. If you don't believe me, the next time you have to pump up a tire or a basketball or something, pump it up and then just try to touch the bottom of the pump where it goes into the hose. And you'll be careful because you might burn yourself. I mean, seriously burn yourself if you pumped a lot. Anyway, compression, not friction. Many ancient writings have discussed the fall of stones from the sky. Pliny and Plutarch both mention the fall of Aegospotami, or Goat's River, in Thrace, which was once part of Greece and now is in Turkey. This was said to have happened in, what happened there, in 467 BCE. But the scientists of the Age of Enlightenment couldn't believe that stones could fall from the sky. But they kept on falling and falling. In the late 18th and early 19th century, the number of meteorite falls made them believe that stones could fall from the sky. So Aristotle and then later Newton, Isaac Newton, said that space was empty except for the stars and the moon and the planets. So the scientists had to come up with all sorts of, we now think some of them are pretty kooky explanations for the falling of stones. Ejecta from Earth's volcanoes, or exhalations from a crack in the Earth's surface. The gases rising from the Earth would go up and condense in the upper atmosphere and form stones that would get so big that they would then fall down. Or stones lifted from the Earth's surface by wind. Or ejecta from volcanoes on the moon. Or collapse theory of terrestrial comets. Here's a good-looking young man. This is Ernst Florenz Friedrich Chladni. He published this paper in 1794. So in case you don't read German, there's old Ernst himself. What that means we can translate to on the origin of iron masses found by Pallas and others similar to it, and on some associated natural phenomena. This paper earned him the title to be called the father of meteoritics. Peter Pallas was a German scientist and explorer, and in Siberia he found this mass of mostly iron that the natives in the area said fell from the sky. He was an Enlightenment scientist, so he didn't believe him. So, our meteorite studies, in November 2001, we hosted an event for the Leonid meteor storm. Not meteor shower, it was a storm that year. It was predicted, and we believed the prediction. We had we had over 1,000 people here. most of them, or at least a good proportion of them, spent the entire night here. And as part of that event, Ron Farrell, who is a Connecticut meteorite dealer, loaned us a collection that was worth between $250,000 and $500,000. Individually by retail, that's what it would be worth. So we, and they weren't under lock and key. We had them here on display, and people could hold them and pick them up and sniff them, or listen to them, whatever they wanted. But it wasn't under glass. We could pass them around. And then in July of 2006, an astronomy educator named Larry Pavel from Illinois donated to the observatory a wonderful meteorite collection. And we've used it over the years to excite lots of our visitors. It really is special. And then last year in June, our board of directors voted unanimously to purchase a meteorite dealer's private collection for $6,000, with the provision that a fundraising effort to reimburse the observatory would be started and continued until paid off. Now here's what Larry Pavel gave us. Allende. So, two kinds of meteorites. A fall and a find. If someone finds a rock and it turns out that it was a meteorite, that's a find. So what information do we have about it? We know where it was found. That's all. That's all we know about it. And there's a fall. Allende was a fall. A fall is when it's observed as a meteor going through our atmosphere and then is subsequently recovered when it lands on Earth. So right then and there, you know when it happened, the date and time, or approximate, and you know the approximate trajectory it took, the angle and its azimuth, because it was observed. So this fell in 1969, 50 years ago, right? Well, you know what else happened 50 years ago? The first moon landing that brought back the first moon rocks. So NASA in Houston had a great big laboratory all ready to go, waiting for those moon rocks to come back. They wanted to examine them. And so this fell just prior to the first moon rocks, so they took it right up to Houston and they analyzed them and did everything to them, and about 2,000 papers have been written on Allende. 2,000 kilograms of it fell. This is a kind of special meteorite. It's called a carbonaceous chondrite, and so there's a lot of carbon in there, and some of the carbon is in the form of microdiamonds. Here's Campo de Sio. Now this is a find. This was found in 1576, but a lot of it. An iron meteorite found in Argentina. Wan Chang fell in 1997. There's a story that some of it went through a thatched roof in China and into a guy's soup pot. But we sniffed it and tasted it, and it didn't taste like egg drop soup, so we figure it's one of the others. Mundrabilla was a find in 1911 in southwestern Australia, an iron one of the biggest falls, around 17,000 kilograms of it. What's that, 34? It's about 40 or so thousand pounds.
That's pretty big.
Yeah.
Pretty big compared to a quarter.
Yeah, it was a big fall.
So they split it up, broke it up, and
Oh no, the
Yeah,
atmosphere does that for us.
Yeah.
Even iron meteorites
So they
are
find
not
the
strong
pieces.
enough to withstand the pressure that's involved of that high velocity passage through our atmosphere. It just, even the iron ones, it tears them apart.
Shatters.
It's a rare meteorite that doesn't break apart. Nyabandi fell in Burkina Faso in Africa in 1956. Odessa was found in Texas, 1922, another iron meteorite. Uh, there's conjecture that this was part of the same fall that put the hole in the ground in Arizona, which we'll see in a minute. And Sikot Alin, another iron one that fell in 1947 in Russia, in maritime territory that's on the eastern edge, north of Japan, near Vladivostok, in Siberia. But look at how much was recovered. 27,000 kilograms. That's well over 50,000 pounds. A lot of it. And some of it was big enough to put craters in the ground. There's one crater at least that was 500 feet in diameter, and there's other craters, 100 feet and less. But yeah, it was a big fall. And then Don Merchant was the meteorite dealer whose collection we bought last June. And it is just a fabulous collection because it was his private collection. He was a long-time meteorite dealer. And this was his private collection. So it's a fabulous collection of over 225 localities. Meteorites are named for the nearest town to where they're found. If it's a really isolated area, then the nearest prominent geological feature. That's the way they're named. So mostly the names indicate where they are from. So this collection contains specimens from all continents, includes many that are rare and many that are very historic. A few are just no longer obtainable. There are several meteorites that have come from the moon and several from Mars in the collection, and almost all different types of meteorites are included, and they all have a story to tell. This is one that's near and dear to us, Alma-Ata Sita. That's a strange name for it. And what that means is Station 6. I'll show you a picture of Station 6 later, but it's in the Sudan on the British railroad that they built in the Sudan. And this fell October 7th, 2008. Okay? But look at this. We observed it. This was the first asteroid discovered that subsequently hit the Earth. It was discovered out in Arizona by the Mount Lemmon survey. 20 hours later, it hit the Sudan. And we were one of the last observatories. This is our field of view of the last frame that we got it in. This was 15 minutes before it flew into the Earth's shadow and then was not visible until it hit. And about an hour and 10 or 15 before it hit was this sequence here. At the time, it was moving at an unbelievable 704 arc seconds per minute. So this whole sequence from one edge of our field of view to the next was about 45 seconds. These are half-second images. Anyway. So this is from the NEODIS page, the Near Earth Objects Dynamic Site, run by a guy named Andrea Milani. from the University of Pisa, who I've met and talked to before. But this is the last page of the 589 observations that have been made. This is part of the last page. You come down here, it's all on the asteroid designated 2008 TC3. That's the provisional designation that the Minor Planet Center gave it. Now if you come over here and you look here at the observatory code 932, that's right here, observatory code 932. We were the next to last to observe it. Our residuals were very low, even though it was moving so quick, and it was accepted. The next observatory was 473 was Rimanzico in Italy. Their residual wasn't so good, and at first it was not accepted. The difference in time, it says date. It's not really a date. This is a time. This is a time specified in a decimal day. 5 decimal points, that's 100,000th of a day. So the difference between this number and that number is 25 seconds. So they got it 25 seconds before or after our last one, and it had flown into the trees for them, but it was only moving half as fast. So we're really proud of that observation. Here's the first picture of what it was like. That's the dust trail left over and blown around by the different altitude winds. That's from the Sudan. Here's a picture of it under a polarizing microscope. This has cross polar filters, and what that does, it brings out these beautiful colors that will allow you to determine the minerals composition of the meteorite. Here's station 6. And here's a picture of me 7 months after we observed it. I was at a scientific conference in Prague, and I'm holding a piece of it, and the picture was taken by Peter Jeniskins, who's a scientist who went to the Sudan and found the meteorite, known as Alma-Hata Sita. And here's Peter Jeniskins with the big grin on the right, showing off a piece of the meteorite to Zendak Seplica, who did that nice diagram that I showed you before, what it all means. Unfortunately, Dr. Seplica didn't last too long after this picture, and he's no longer with us, but he had been working on asteroids forever and meteorites, and he wrote the paper about the first meteorite that was imaged from multiple stations simultaneously in the Czech Republic, and from that they were able to determine its orbit. So this was the first instrumentally determined orbit of a meteorite. And he did that 50 years ago in 2009, so in 1959. Really a famous scientist. But at the same time I was in Prague, the gentleman that's up running a telescope on the deck, Bill Cloutier, was given NASA press credentials to go down and observe and write on the one of the last space shuttle flights, and it was the last to go and service the Hubble telescope. But I love this over here. This is McCarthy Observatory leader, an expert in manned spaceflight, and excellent writer. And he is both. So say hello to Bill if you haven't been up on the deck yet. But while he was down there at Cape Canaveral, Cape Kennedy, he bumped into the guy on the right here, Gerard Kuiper. He's a meteorologist by trade and a member of the Dutch Meteor Society. So he checked into work. He also works with KLM and I believe SAS also. Anyway, he checked in and was doing his business, had a break in what he was doing, and he checked his email, and my goodness, here's a email saying, hey, the Earth's going to be impacted tonight by a newly discovered asteroid. And they know, there's 589 observations of it in the 20 hours from when it was discovered until when it hit, but there was enough observations made quickly of it that they knew where and when it was going to hit, and knew very accurately. Both NASA, the Jet Propulsion Laboratory, part of NASA, and the Minor Planet Center up here in Cambridge, Massachusetts, they knew where and when it's going to hit. So what Kuiper did right away was get in touch with KLM's dispatch office and said, hey, please contact all of your flights over Africa tonight and let them know that they should look towards the Sudan at about 2:45 in the morning, Universal Time, and see if they can see a meteor. This is Captain Ron Duporter. He was flying a KLM 747 from Cape Town, South Africa, to Amsterdam. And over Africa that night, they looked and they saw the meteor. And so this was the world's first real confirmation that hey, they were right, the Minor Planet Center and JPL. That's exactly where and exactly when they said it was going to hit, it did. So that's what Bill did, talk to him. Here's Chelyabinsk. So this fell in 2013. Anyone here speak Russian? Good. Then maybe I can show you a little video of it. The reason I say good is because there's some bad language in Russian. Can you excuse me?
We'll just ignore that.
I'm sorry. So apparently there's some pretty bad language in here. This fell February 15th of 2013, just south and west of Chelyabinsk, which is in the Ural Mountains, about 1,000 miles east of Moscow. And people saw the bright light, and then they saw the vapor trail, and they said, wow, what was that? And so they're out there wondering and looking up. The ones that had video cameras were taking videos of it. They didn't know what was coming. These are fairly rare events.
силы и средства РСЧС
They didn't know
и
the
МЧС
shock
России
wave
были
was
приведены в
coming.
режим повышенной готовности. Это более
And
20
when it hit, you
тысяч
can
человек,
see the
которые
people that had
приступили к
handheld
разведке
cameras,
территорий, уточнение обстановки. По
almost
состоянию на 10 часов
100% of them
30
dropped
минут
the camera.
по
Or they
результатам
fall
проведенной
over.
разведки и обследования
Because it was a
было
loud
выявлено, что
explosion, and
радиационный фон на территории субъекта
it kept
Российской
on
Федерации
going.
находится в норме. Системы,
So
объекты, энергетики,
when it
связи,
really flared
транспортной
up right here,
инфраструктуры.
about 30 kilometers in the air, and anyway, so the
There were also thousands of people who got hurt
There-
because they
yeah.
were at the windows.
there were, that's right, there was at least, there was about
Crashing down to earth today.
12 or 1,300 people that,
People running for cover. Parts of the meteor fell in the city of Chelyabinsk. Population over 1 million. About 1,000 miles.
anyway, there was 11 or 1,200 people that had to go to the hospital, mainly from being cut by a flying glass. It happened right after, right about sunrise. People were already at school, at work, not everybody, a lot of people. But they hadn't experienced this before. And so they see the bright light and they all go towards the window. What was that? They look up, oh, look at that. What was that? They don't know that shock wave is coming. The meteor is going quickly and it's out of there. It's gone. But the shock wave travels at the speed of sound. And from 30 kilometers, it takes a minute and a half to get to you. And so, luckily, no one was very seriously injured. No one died from it. But we've got a piece of Chelyabinsk now. This was, yes,
How big was that meteor?
about as big as this observatory building, about 20 meters in diameter. Now, they always say that. They give you a diameter of it like it was spherical. They're not. They're usually the small ones, like this, are usually irregularly shaped. A lot of them look like potatoes, lumpy potatoes. But nonetheless, they can inflict quite a bit of damage. This was the most powerful impact on Earth in over 100 years. Yes.
How far did the shock wave travel?
Well, far enough to break windows, on the order of maybe 30 miles.
Did we here in America feel anything from that
I don't think
over time?
I don't think we did. However, the infrasound system that was set up, an international program to set it up. What it is a recording, a sound recording of the sound waves that are too low for us to hear.
What would the time frame be from something like that?
Well, that's what gives them a lot of information on where and when this was, because there's stations all over the world. They were put in to try and detect nuclear explosions of people testing bombs when there's a test treaty. We're not supposed to be experimenting with nuclear weapons. So that's what the infrasound stations were set up to do. But it went around the Earth a couple times that they could determine.
Did anybody get any kind of effect from that?
I don't think so. No. Now close in, yeah. I mean,
Well, I meant farther away.
No.
No, from that.
But close in, there was the nearest seismograph. It was like a magnitude 2 point something on the Richter scale, which is enough to move furniture around in the buildings and break windows, which it did. All right, here's another one from the collection, Ensisheim, Look at the date on that. That fell in 1492, the year that Columbus sailed the ocean blue, right? Here are the guardians of the meteorite. They have all sorts of rituals, and it doesn't show their spears, but they walk around guarding the meteorite. This was a contemporary woodcut of it that was published. It was found by a young boy out in the field. It happened in the daytime. Most meteorites actually fall in the daytime. So he's out in the field, and this thing landed not too far from him. He ran into the village and told the elders, and they came running out and started chipping away at it, and the mayor came out and told him to stop it and took it to the church. Canyon Diablo. Canyon Diablo. That was the one that Odessa might have been paired up with. That's a picture I took of the impact of Canyon Diablo just near Winslow, Arizona, meteor crater. And so that was taken from 37,000 feet. But that's what it did to the Earth. This iron meteorite that fell between 30 and 50,000 years ago, probably about the size of a school bus, maybe a little bit bigger, but made out of iron. That's 3/4 of a mile in diameter and 570 feet deep. Gene Shoemaker, a wonderful, wonderful guy. He wanted to go to the moon, but he had a disqualifying medical condition, so he studied impact craters, and he died in 1997 in an automobile collision on a dusty dirt road in Australia. But he died studying impact craters. But he's the one that proved that meteor crater was in fact a meteor crater and caused by the Canyon Diablo meteorite. So all I'm saying is now is the time to develop the technology to deflect an asteroid. Here's Peekskill. This is the closest meteorite that's fallen to us. Fell in 1992. Bill Cloutier was on an airplane with his family going down to, they were going to land in Raleigh, Durham, and then take another flight to someplace else. And so one of his daughters was sitting at the window seat, but she was snoozing. He was reading in the middle seat, and a woman that he didn't know was on the aisle seat, and his wife and other daughter were a couple rows behind. And so he's reading, and all of a sudden the woman next to him grabs his arm and says, "Look, the wing's on fire, the wing's on fire." And he looked out, and he very quickly realized it was not the wing on fire, but it was a meteor. And so anyway, this fell not far from here over in Peekskill, New York on the Hudson. And now let's see if we can get this to work. Oopsie, come on now, you can do it. That's not what I want. Let's go back one, right? So it was a Friday night in October. It's football night, so lots of people. Well, that didn't work, did it? Lots of people had their video cameras. And they took videos of it flying through the air. Let's see if we can get that other one to work. Where's my mouse here? Yeah. They broke up in a whole bunch of different pieces, but they got about 15 videos from all across the country. It came in at a very shallow angle. And what happened was it hit this car. Michelle Knapp was a junior or so in high school. She had just 3 weeks before, because of her working and going to high school, she could finally afford a car, so she put $300 down and bought this old Chevy Malibu. And she was sitting in watching television that evening, and she hears this thing that she thought was a car accident. She looked outside, didn't see anything. The next morning they found that meteor, right, hit her trunk. A gal came and bought the car, I think for $50,000 from Michelle Knapp. So she didn't have to get it repaired. She was, for a high school kid, wealthy then. But the gal that bought it from her sold it, and the company took it on a world tour, and it's been around the world a couple times. Come see the car that the meteorite hit, big deal. Last I knew, it was back in the United States, and it had a for sale sign on it for $250,000. You can own Michelle's junked car. Here's New Orleans. It fell in 2003. A family came home. A man and his wife came home after work. I think they had a gift shop, something like that, in New Orleans. They'd been remodeling their bathroom. As they approached the house in the darkness, they felt something was strange. They didn't know what, but something seemed off. And they went in, and they saw a hole in the living room ceiling and a hole in the living room floor. They ran upstairs and through the newly remodeled bathroom, missing the toilet by a foot. A hole in the floor, hole in the ceiling. They found pieces of it in the basement. Anyway, here's one that happened a little bit earlier that same year, and it says Cook County. They call it Park Forest, but if you know Chicago, it's just part of Chicago. You can't tell when you leave Chicago and enter Park Forest. But anyway, this one of the pieces went through an apartment roof, through a ceiling, hit the floor of a 12-year-old boy, bounced up, hit the ceiling again, and then traveled down his Venetian blinds. If you can imagine what a rock sounds like coming down Venetian blinds. So he pulled the cover up over his head and called for his mom. Oops, I'm going the wrong way, aren't I? I'm sorry. Walled Cottage happened in 1795. Lost City was the first in the United States that was the orbit was instrumentally determined. And the second one in the history of the Earth. Here's a historic one that landed in 1803 in France, in Normandy. And here was my friend. You giving me the hook, are you? Yeah. Anyway, this particular piece here, you see, it came from Rob Elliott with a trade from the Natural History Museum of London. I'll go quickly through this. So here's the deal. Monica Grady, the keeper of the meteorites, had an exchange with Rob Elliott, and she gave him this particular piece right here of Weston. It was the British Museum specimen 90253. Here's 90253, and above it says equals Koning 30. Koning was the first keeper of the meteorites at the British Museum, and here's his handwritten catalog. So number 30 was from the Greville collection. In 1810 they got it. And 30 on the next page says fragment weighing 32.5 grams. Well, grains, that's grains, that's grams. Fell in December 14th in Weston, Connecticut. So here's the Right Honorable Charles Greville, who died shortly after Weston fell, and Weston fell again in December of 1807. He died in 1809. He had the largest collection of minerals in Europe at the time, and so the Parliament resolved to buy his collection for £13,000. Anyway, this was the first. So we have the piece that was the first piece that the British Museum ever got of this particular meteorite. Anyway, this is a paper that I wrote about it, and here's a aerial survey I did that shows where it landed over, and that's the Easton Reservoir there. So it was 20 miles from there is where it landed. So thank you. That's all I have. If you have any more questions, I'll try and answer them.